Welcome pre-cal students to the homework help video. Actually, the review sheet help video. Let's go ahead and get started with page 900 right here, numbers 1 through 61, every other odd. Numbers 1 through 9, you are going to prove that one matrix is the inverse of another matrix. And of course, the way to do that is to multiply the two matrices together, and you should get out the inverse matrix. So very quickly, here we go. This matrix here is a 2 by 2. This matrix here is a 2 by 2. Your inside numbers match. Your outside numbers are a 2 and a 2. So you know your answer would be a 2 by 2. So we take our first row times this column here. 2 times 3 is 6. 1 times negative 5 is negative 5. So 6 and negative 5 would give you a 1. Then you take row times this column here. So 2 times negative 1 is negative 2. 1 times 2 is positive 2, so we get out a 0. Now we take this row here times this column right here, okay? So 5 times 3 would be 15. 3 times negative 5 is negative 15. Combine those together and you get a 0. Then we're going to take this row here times this column right here, and we get 5 times negative 1 is negative 5. 3 times 2 is positive 6. Combine those and we get a 1. So, when we multiplied these two matrices together, did we get out the identity matrix? Yes, we did. So we confirmed that they are inverses. Okay, same thing here. So here we go. Let's grab this thing here and slide it over. And then very quickly we'll copy this matrix up here. 1, 2, 3, 1, 4, 6, 2, negative 3, negative 5. And here we go. Notice we have a 3 by 3 here and a 3 by 3 here. So your inside numbers do match, and your outside numbers will be a 3 and a 3. So your answer is going to be a 3 by 3. And so here we go. Row times column. 2 times 1 is 2. Negative 17 times 2 is negative 34. 3 times 11 is positive 33. Add those numbers together and you get a 1. Then we're going to take that row times this column here. So here we go. We have 2 times 1 is 2. Negative 17 times 4 is negative 68. And 11 times 6 is 66. That would give you a 0 if you combine those numbers. Now we're going to take this row here times this column over here. And so here we go. We have 2 times 2 is 4. Negative 17 times negative 3 is positive 51. And 11 times negative 5 is negative 55. So we get, let's see, this would be 0. Alright, moving on to the next column. So we'll grab this here. We're going to take this column here times this row, or take this row here times this column right here. 1 times negative 1 is negative 1. 11 times 2 is positive 22. Negative 7 times 3 is negative 21. And you will get out a 0. Now we're going to take this row times this column here, and we have 1 times negative 1 is negative 1. 4 times 11 is positive 44. And negative 7 times 6 is negative 42. That would give you a positive 1 if you add those numbers together. Then we'll take this row times this column over here, and so we have negative 1 times 2 is negative 2. 11 times negative 3 is negative 33. Negative 7 times negative 5 is positive 35. And so that would give you a 0 if you added those numbers together. Alright, now let's continue on. We're going to take this row here times this column here. And so here we go. 0 times 1 is 0. 3 times 2 is positive 6. Negative 2 times 3 is negative 6. So we get a 0. Now we're going to take this row here times this column here. So here we go. 0 times 1 is 0. 3 times 4 is 12. And negative 2 times 6 is negative 12. So we get a 0. Then we're going to take this row here times this column here. 0 times 2 is 0. 3 times negative 3 is negative 9. Negative 2 times negative 5 is a positive 10. And we get out a positive 1. Okay? A positive 1. And so we're doing pretty well, actually. Okay? Alright, moving on to number 9. Oh, by the way, Yes, these two matrices are inverses of each other because when you multiply them together, you get out the identity matrix right here. Okay, this one here is going to have a fraction, so there's no way I'm going to make you do all that multiplication. So here's what I would do with you if I were you. Take your calculator, and I'm going to do this in just a second. You're going to enter this in for matrix A. Then you're going to take this and enter it into your calculator for matrix B. And then what you're going to type into your calculator is this. You're going to type 1/3. And then hit matrix B. Then hit matrix A. And then hit enter. Okay? And we'll see what you'll get. I'm going to go ahead and do that now. So I'm going to grab my calculator and I'm going to type in my first matrix. It's a 3x3. And here we go. Okay, here we go. And yes, you do get out the identity matrix when you type this into your calculator right here. And so yes, these two matrices are inverses of each other, okay? Alright, number 13. The directions say to find the inverse of the matrix if it exists. So here we go. Let's find the inverse of this matrix here. First of all, you got to find the determinant. So 2 times negative 2 is negative 4. I'm going to put a positive 4. 1 times negative 3 is negative 3. So the determinant is 1. Now remember, you take this number and you flip it. So 1 over 1 when you flip it is 1. So we put it right here outside the matrix. And then next, these two numbers here, we change their signs. So this positive 2 becomes a negative 2. And this negative 2 becomes a positive 2. These two numbers here, we swap places with them. So the negative 3 goes up here and the 1 goes here. Next, you take this number here and you multiply it through the matrix. Obviously, this 1 won't change anything. So there's your answer. This matrix here is the inverse of this matrix here. Alright, number 17. Here we go. Find the determinant first. 4 times 4 is 16. I'll put a negative 16. 2 times 8 is 16. So the determinant is 0. Now students, this matrix here, are you ready? It has no inverse. Okay, it has no inverse. And here's why. The determinant is 0. So it's really 0 over 1. So when you flip that, you get 1 over 0. And students, you should know by now, you can never have 0 in the denominator of a fraction. So anytime a square matrix has a determinant of 0, you cannot have an inverse. There is no inverse matrix for this matrix here. Okay, moving on to number 21. Okay, I told you guys in your notes, any matrix larger than a 2x2, we're going to use our calculator. So very quickly with my calculator here, I'm going to type in this matrix. And let's see what we get here. Here's the inverse matrix for this matrix. According to my calculator, as long as I typed in everything correctly, it's 1, negative 3, 3, 1, 2, negative 3, negative 1, negative 1, 2. Okay, so this matrix here is the inverse of this matrix here. Alright, number 25 is definitely larger than a 2x2. So we're going to have to use our calculators, okay, to find the inverse of this matrix. So we have a 4x4. Okay, students, the inverse for this matrix here has has some decimals in it, so I went ahead and I hit math, enter, enter. So mine is in fractions, so the inverse is negative 1/8, and then a 1 here, and then a 1/4 here, and then a negative 1 here, and everything else is zeros. And this matrix here is the inverse of this matrix here. Okay? Alright, moving on for number 29, 33, and 37. They tell us to use our calculators to find the inverse. So really, this is pretty redundant and pretty simple. So here we go. Go ahead and type this into our calculator and get the inverse matrix. And if you're finding this really easy, then be thankful, because a lot of the math that we do is difficult. Okay, the inverse matrix for this matrix here is, and I converted mine over to fractions, I'm getting negative 3 halves, 3 halves, 1, 9 halves, negative 7 halves, negative 3, and then 1, 1, 1. This is actually a negative 1 right here. Okay, so this matrix here is the inverse of this matrix here. Okay, number 33. Let's find the inverse of this matrix here. So here we go. And here we go, students. The inverse matrix for this matrix here would be 0, negative 10, 10, negative 20 over 11, 5, negative 30 over 11, 10 over 11, 5, and then negative 40 over 11, okay? So there's the inverse for this matrix here, using a calculator. Alright, number 37 is a 4 by 4. So here we go, let's enter this into our calculator. And the inverse matrix for this matrix here would be 1, 0, 2, 0, 0, 1, 0, 1, 1, 0, 1, 0, and then 0, 1, 0, 2. Okay, so this matrix here is the inverse of this matrix here. Alright, moving on to number 41. The directions say to find the inverse matrix. And so here we go. Multiply up, that's a negative 12, so I'm going to put a positive 12. Multiply down, that's a negative 12. You get 0 for the what? For the determinant. Please don't forget, students, that anytime you get 0 for a determinant, that means there's no inverse matrix. So there is no inverse matrix for number 41. Alright, moving on to number 45. We're going to use an inverse matrix to solve this equation. Now, first of all, remember, I've told you on a test or a quiz, when you're solving a system by using inverse matrices, you are more than welcome to use a calculator all you want to. The first thing you do is you write your coefficient matrix. Next, you write a matrix here with your unknowns, your variables. Then an equal sign. Then you put your constant terms right here. Okay, now the next step is you find the determinant of this, you find the inverse inverse of this matrix here, okay? And then you multiply that inverse matrix times both sides. So let's find the inverse of this matrix right here real quick, okay? Okay, let's find the inverse of this matrix. Multiply up -4, so I'll put a +4. Multiply down -3, so I get a +1. So when you flip +1, then you get a 1. Okay, these two numbers here, we change their signs. So I'm going to have a -2 here and a +2 here. These two numbers here, I swap places. So -3 here and a +1 here. Multiply your 1 through, and this is your inverse matrix. Right here, okay? So, with that in mind, let's go ahead and slide this back up here. So we're going to take our inverse matrix right here. And we're going to multiply it times this side of the equation, but we're also going to multiply it times this side of the equation here. Please don't forget, students, that when you do this, the inverse matrix must come first right here, okay? It must come first. So over here, these two cancel out, so you're left with xy. And then here, multiply these two together. We can do it probably quicker than a calculator. You get -15 and +20. So that would give you a 5 right here. And then -10, +10, you get a 0 right here. So x equals 0, y equals 5. Now students, you might say, Mr. Earhart, where did you get 5, 0? I took this matrix here times this matrix here. So there's your answer. And that's it. So there's your answer, 5, 0. Okay, let's try number 49. The directions say the exact same thing. Let me go back and look at something real quick. Okay, they're telling us to use this matrix right here from number 21. So if you'll read the directions very carefully for number 49, if you'll read the directions, it says to use an inverse matrix to solve the linear system. And it says use the inverse matrix from number 21. Okay, so we're going to do that in just a second. Okay, students, here we go. Let's go ahead and write our coefficient matrix first. So 1, 3, 3, 1, 5, 6, 1, 4, 5. Okay. Next, we're going to write our variables here. X, Y, Z. Next, my constant terms go over here. 0, 5, 2. Now, students, next, we would find the inverse of this matrix here. However, if you'll look at number 21, you will see this matrix here is the exact same matrix we used in number 21. So we've already found the inverse of this matrix, and it's right here, okay? So I'm going to grab this here, and we're going to pull it somewhere. And let's take this here. Let's shrink this a little bit. So we're going to put our inverse matrix here, and then we're going to put our other inverse matrix right here. Remember, students, on the right side over here, always put the inverse matrix first. Okay, these will cancel out, leaving you with X, Y, Z, okay? And then with my calculator very quickly, I'm going to type these in and multiply them. And students, when you multiply these two matrices together, you will get 22 18, negative 37. So there's your answer for x, y, z. So your answer is 22 for x, comma, 18 for y, comma, negative 37 for z. Okay, there we go. Moving on now to number 53. Number 53 says use an inverse matrix to solve. Okay, so we're doing the exact same thing again. So here we go. Let's first of all write our coefficient matrix. 3, 5, 4, 3. Okay, then right here we're going to put x, y. Then over here we're going to put our constant terms, negative 2, 4. Now, I can probably find the inverse matrix faster than using a calculator, to be honest with you. Although you're welcome to use a calculator. I'm just going to quickly go. 20, that's negative 20. 9, that gives you a negative 11. Alright, so if you flip negative into 11, you get negative 1/11. And actually, because I'm getting a fraction, I am going to use a calculator to save time. So here we go. So much for that idea, huh? Alright, let's see here. 3, 4, 5, 3. And here's your inverse matrix right here. And it's problems like this you're going to be very thankful you can use a calculator, because these fractions are going to be a pain over here when we multiply it times this matrix. Alright, so there we go. So let's multiply these two matrices over here. Of course, these cancel, leaving you with x and y. And here we're going to multiply these two together. And you will get this out for your matrix. 10, comma, or 10, 2. So your answer is 10, comma, 2. Okay, there we go. And that cannot be right, so hold on 1 second here. Let's see what we're doing wrong here. Okay, that's incorrect, students. I apologize. And very quickly here, let's see if we can fix this. You will get out. You will get this out right here, students. I apologize. 2, negative 2. So your answer is 2, comma, negative 2. Alright, and let's see if that's right. 6, negative 8, and 10 minus 6 is 4. So yes, that is correct. Okay, number 57. The exact same thing again. So here we go. Let's go ahead and write our coefficient matrix here. Then our variable matrix here. Then our constant term matrix right here. Then let's find the determinant or the inverse matrix of this matrix here. So here we go. And the inverse matrix will be this right here. And we're going to multiply it by both sides. 7/3. Negative 1. Negative 1. And then 1/2. side and the left side to be sure and put your inverse matrix first. And so now we're going to these here will cancel out. So you're left with xy equals, and then we have this times this here. So let's see if we can do this quickly. I'm getting this out right here. 3 and a negative 1/2. And let's see if that's correct. 9 plus 3, or 9 minus 3 would be 6. And 18 minus 7 would be 11. So yes, this is the correct answer. 3 comma negative 1/2. Okay, alright, moving on to number 61. Okay, the first thing we're going to do is write my coefficient matrix right here. So 4, 2, 5, negative 1, 2, negative 2, 1, 3, 6. My variable matrix right here, x, y, z, and then my constant term matrix right here, negative 5, 10, 1. Okay, so here we go. Let's go ahead and enter our first matrix. So students, your inverse matrix is actually pretty weird, but you're allowed to use your calculator, so it's okay. 18 over 55, 3 over 55. And again, students, be thankful. Remember, on any quiz or test, when I tell you to solve a system by using inverse matrices, you're more than welcome to use your calculator, okay? Use your calculator all that you want to. That's what it's there for, and it will save you a lot of time. So students, we're going to multiply these two matrices together. They cancel out, and we're left with x, y, z. And then over here, we're going to multiply this inverse matrix times this right here. Let me grab my calculator and quickly do this. And the answer you will get out will be negative 1, 3, 2. Okay, so there's your answer. Negative 1, 3, 2. And students, that's it for page 900. So again, we're just using inverse matrices to solve linear systems, okay? Alright, moving on now to page 842, numbers 5 and 13, and we're going to use, or 843, page 843, we're going to use substitution on numbers 5 and 13. So number 5, we're going to solve this by substitution. So I'm going to take this x right here and get it all by itself. I'm going to bring this negative y over and make it a positive y. So I have x equals 0 plus y, or in other words, x equals y. Now go to your other equation, and where the x is, I'm going to put a y. So 5, and then for this x right here, I'm going to put a y. Minus 3y equals 10. This is called the substitution method. 2y equals 10. Y equals 5. Okay? Now if y equals 5 and y equals x, then x must also equal 5. So your answer is 5 comma 5. Now let's check this real quick. 5 minus 5 is 0. 25 minus 15 would be 10. So yes, this is the correct answer. Okay, let's try another one using substitution now. Probably the easiest number to get by itself, or the easiest variable to get by itself would be negative x, okay? So if I bring this over and make it a positive 5/6, then I have this. Negative x equals negative 7 plus 5/6 y, okay? Now, the problem is x is still not by itself. There's a negative sign here. So go through and change all of your signs. X equals 7 minus 5/6 y. So now go to your other equation here, and where the x is, I'm going to make this substitution here. So 6 and then x. So for x, I'm going to put 7 minus 5/6 y plus 5y equals negative 3, okay? So 6 times 7 is 42. 6 times negative 5/6 would be a negative 5y plus 5y equals negative 3. Well, these cancel, so you're left with 42 equals negative 3. Now listen, students, all the variables canceled out. Whenever all the variables cancel out, your answer is either going to be infinite solutions or no solution. Well, because I have a false statement, 42 equals negative 3, then that's going to be no solution, okay? So the answer to this would be no solution. Now you might say, Mr. Earhart, when is it infinite solutions? If I ended up getting 0 equals 0, in other words, all of the variables canceled out, all of the numbers canceled out, and you're left with 0 equals 0, then you have infinite solutions. But the answer to number 13 is no solution. Okay. Alright, 33 and 43 are linear combination. So here we go. I'm going to eliminate my y's because I have a positive 3 here. If I multiply the bottom equation by 3, that will give me a negative 3 here. So my top equation stays the same. My bottom equation gets a 3 being multiplied through. 3 times 5 is 15x. 3 times negative y is negative 3y. 3 times 11 is 33. Okay, add these together, those cancel. 17x equals 51. Divide both sides by 17. X equals 3. Now if x equals 3 in any of these equations, this one or this one or this one or this one, it doesn't matter which one, you can substitute 3 in for x and solve for y. I'm going to use this equation here because I have room underneath it to do work. So here's my x, so 5, and then where the x is, I'm going to substitute 3. 5 times 3 is 15. Bring the 15 over, make it negative. Negative y equals negative 4, because 11 minus 15 is negative 4. If negative y equals negative 4, then y equals 4. So my answer would be 3 comma 4. Okay, let's check that real quick. 6 plus 12 is 18, and 15 minus 4 is 11. So that is correct, okay? Alright, moving on to number 43. Now, students, you may do what you want, but for me, I don't like decimals in my equations like this. It's going to make the problem a lot more difficult. So for my top equation here, I'm going to move all of my decimals one place. So 2.5 becomes 25, 3 becomes 30, and 1.5 becomes 15, okay? Now, move all your decimals one place down here. I'm going to have 20x minus 24y equals 12. Now notice both of these equations can be reduced. For example, 5 goes into all these numbers. So this equation right here now becomes 5x minus 6y equals 3. Now I got that by dividing everything by 5, okay? equation here can be reduced by 2, I believe. No, 4. Okay, so you're left with 5x minus 6y equals 3, I believe. Yes, that is correct. So notice what happens. If I want to use linear combination or elimination, whatever you want to call it, I'm going to try to get my x's to eliminate. So I'm going to make this 5 negative, this positive, this negative. I'm doing that so that my x's will cancel. But in the process of making my x's eliminate, notice everything eliminates. So I'm left with 0 equals 0. Okay? Now, remember, we've learned how to solve these equations for, remember, whenever it's infinite solutions, I want you to write your answer in terms of A. Okay? So here's what we're going to do. We're going to go back here and look at our 2 equations. Okay? Now, I'm going to call y A. So if that's the case, I'm going to go and put A in for y. Now I'm going to solve for x. So this would be 6/5 A plus 3/5. Okay? And there we go. Alright. I hope this first part of the review sheet has been beneficial to you. If you have any questions, this is part 1, and hopefully it's been helpful to you. If you have any questions, don't hesitate to call or email.